Okay, we are going to derive the quadratic formula by completing the square. Okay, so we've already now seen that in practical examples we can solve by completing the square for an equation where we can take the c value to the side and put in the number that would work for a perfect square. So we got that as long as the constant is equal to a half of the b value of my function squared. I add that to both sides, I take this over, then I can have something where it's a perfect square, factorize basically, create a perfect square, and then I can solve an equation by taking the square root, for instance. Okay. We're going to see how it works now, and we've even seen in practice some examples with an a in front. What if we just have these values and try and do the same thing? We'll be able to get the quadratic formula. So if we see over there, our first tactic is, since a is a non-zero number, we'd rather work with x squared on its own. Then we know this constant for a perfect square thing is going to work out. So we'd rather divide each of these things by a. 0 divided by a is just 0. And from here we can do our normal idea for solving. We can say, okay, take this first to that side. Ta-da! And then for a perfect square in this example, I would like to add to this side of the equation, to make it a perfect square, a half of a b over a squared. Or as you can see, this would be a quarter of b squared over a squared like this. Or b squared over 4a squared. Okay? So if I add that to both sides, x squared plus b over a x plus b squared over 4a squared is equal to, I'm going to add it to this side again, 4a squared minus c over a. Okay, this is still equal, both sides, because if it were numbers, for instance, and I say 3 is equal to 6 over 2, if I add 1 to each side, it's still equal, okay? This is still equal to 4, this is still equal to 4. It's true still. So I can add the same number to both sides. Now I didn't do this for no reason. Don't go back and like substitute or take all these to the same side now and get back to our original equation. That's not going to help us. We did this for a reason, because it's a perfect square. We can then say take the square root of this, take the sign from here, take the square root of this squared is going to be equal to that. And then on this side, we just have our b squared over 4a squared minus c over a. Okay, so in order to solve this, I can go and take the square root on both sides. Whenever I take the square root on both sides, I'm going to have a plus or minus as the answer for this. Could be equal to plus or minus b squared over 4a squared minus c over a. Okay? So now I have something that kind of looks nice. I want to preferably solve for x. Okay, so I'm going to take this over and make it minus b over 2a. Okay, in this case I still have my plus or minus. Let's make it into one nice fraction in here. Okay, so I can put all of this over 4a squared. I need to multiply the bottom by 4a, so I'm going to multiply the top by 4a. Okay, 4a times c, we get this. Okay, this already looks very familiar. Okay, I know with square roots, one of my rules is I can go and decompose this thing or rewrite this thing as, I'm just going to write ac so it looks a bit neater, over the square root of the bottom as well, 4a squared. I know what the square root of that bottom is, it's 2a. So guess what? They're both over the same common denominator, 2a minus b and plus or minus b squared minus 4ac. And there I've derived my quadratic formula by using completing the square. So we can see this is a valid, useful technique and how it can actually be used to get a general formula for us. Okay, so hopefully this was insightful. Come and ask me if you have questions.